Good morning. Today we're doing a simulated gel electrophoresis. I'm on campus today, but I'm not with you guys because they have me working on next year's ninth grade science curriculum. So, uh, first thing, read this page. It's page 10. It goes over what the situation is. So there was a robbery in a museum, and your task is to figure out which of the four suspects committed the robbery. So these are the four suspects. Read this page. There's some silly DNA jokes that you might find amusing. Next, I'm going to page 3, and this basically gives you an overview of the first step in a gel electrophoresis, which is the restriction enzyme. So we watched a video on restriction enzymes on Friday, but basically what a restriction enzyme is an enzyme that cuts DNA, and it cuts DNA in a specific place. And in this case, this is HAE3. This is the name of an enzyme, and this specific enzyme cuts every time it sees a CCGG. So here's DNA 1. This represents from a person, and you can see that they have CCGG right here, and the scissors cut between the C and the G's, right between the C and G's, just one cut. If when you're doing the cutting, make sure you look at this example and see that the cut is between CC and GG. So you can see this is the completed DNA, and then the restriction enzymes cut it into 4 pieces. Again, there's another CCGG, make one cut between the C and the G. Again, over here, make one cut between the C and the G. The reason why they're showing 2 DNAs, DNA 1 and DNA 2, is this is showing that 2 people would have unique DNA strands, and because their DNA sequence is unique, it would get cut into a unique. The restriction enzyme cuts it in different ways. This DNA gets cut into 4 pieces. This person's DNA gets cut into only 3 pieces. So a person's DNA is unique, and therefore restriction enzymes will cut it in a unique way, but still obeying the CCGG rule. And then if we scroll further, you can see this is a diagram of what the gel electrophoresis would look like. And you can see that this is the DNA bands from number 1. So 1C, 1D, 1B, 1A. So that corresponds to the pieces that the DNA was cut into. So this is the DNA from person 1. This is the DNA from person 2. So because the lengths were different, the pattern of bases is different. Okay, next step. What are we going to do? Okay, next step is shoot. I'm going to cut there, and this will be step 1.